All right, well, listen, thanks for joining us after lunch. I want to take you through a story here. It's kind of your AI, your artificial intelligence, needs an infrastructure agenda. And probably unlike most IBM presentations, I bet you half to 3/4 of this will have nothing to do with IBM. I'm going to talk about your AI. But I think I'll level set with a fable, an Indian fable about the invention of chess. The king of India, or the emperor, was bored, and he challenged his court to come up with something that could entertain him for the years to come. And people came back with all these solutions, and one was the game of chess. And the reward for the king's choice was anything in the kingdom. And they asked this individual who invented chess, what did you want? And he said, I'll take a grain of rice. And for every square, I would like it to double. And everybody laughed. Well, they laughed because after 8 squares, or 5 squares, you're at 31 grains, right? You move across to the 10th square, 8,000 grains. Well, what would happen if you actually gave and fulfilled this wish and this promise? You would probably have about 1,650 times the world's rice production in 2014. So why am I talking to you guys about rice? This is where we are today. You're in the middle of the chessboard, which means every square you advance, tech years are like dog years. This is a lift, shift, rift, or cliff moment for organizations and individuals in their careers. You guys are way ahead of this line, obviously. You're looking at the lift and the shift because of the profession you're in. And if you don't believe me that this will be an epoch in human history, the agricultural revolution lasted 8,000 years. 8,000 years, and suddenly we had an industrial revolution, but that half-life was about 120 years. And then just under a century later, that was invented. We have electricity. Then we put a man on the moon, but 22 years after electricity. And then the World Wide Web was born, not even a decade later, and then we mapped the human genome. This is a moment in human history. And it's a moment in history because we've never had so much data. And I've gone through the years of the database, the data warehouse, and the data lake. And so you look up here, and this represents your data today. And on the left, you're probably thinking the IBM guy shows a picture of a mainframe DBA, right? But that's not really what that is, right? What that is a data warehouse. And that is a traditional way of getting insights out of data. We know there's a lot of value. I can see the gold. It's visible to the naked eye, and I invest in it. And that is not going away. But just like in gold mining, we have new capital equipment that will let us process millions of tons of dirt, low value per byte data, to find near invisible strands of gold. We have the same types of technologies and epochs, if you will, from Object Store and Hadoop and other things going on in the warehouse. And on that side, it's kind of not visible to us. And so the different ways in which we package that data into our enterprises might be schema first, schema never, schema on read, schema on write, whatever it is, this is where all the data is. But there's a problem. And the problem is the way in which we ingest data is like an A+ grade, and the way in which you understand the data is right here. And you can't get better on your own because the velocity of that data coming into the organization is going way too fast. And so you look at these hybrid environments, yet we're not getting value out of the data. And as it turns out, in this hyper-personalization world, we talk about precision agriculture, precision medicine, precision retail, and technology is going to enhance that precision experience. And so we're going to have to identify and how we can use technology to change things. So I'll show you an example. So here, I'm going to go through, and I loaded up a bunch of car images, and I'm going to go and generate, that comes out nice for me, a histogram of oriented gradients. Let's go see where I got here. Unless, of course, I didn't set myself up good. Oops. Well, I was going to show you that, but I'll show you something different now. So you can imagine, I just connected to the internet, so I was trying to pull some stuff down. You can imagine now I've gone and looked at a logo of a car logo, and I'll generate a hog, right, which is a representation. This is how we do face recognition. And so imagine how we change precision advertising and that's the hog, that's what we were going to generate. And as the car is driving down the road, Lexus wants to go and target that particular car. And it finds it because of the histogram-oriented gradients, and it hits it with an ad. Right? This is what I'm talking about, of precision. Or you look at smoking cessation in Sweden, where they have an enormous smoking rate. And as you walk by this live billboard and you exhale your cigarette, it actually recognizes that you're smoking and who you are, and audibly notifies you that, hey, you're smoking, and here's something to kind of help you quit. Right? It's a different level of engagement. Or you think about how can we use computer vision around driver attention or emotion detection. And let's go see if my internet connection has come back to me now. We'll try this one here and see what we get here. Okay, so that looks like it's popping up. Okay, there we go. So I'm going to go show you some emotions that are coming off my face, if you can see that. And so like when that internet connection didn't work, like, oh, look how angry I am, right? You see how angry I am? And oh, so surprised and happy. And these are emotion detections that we can pick up from that camera. Or what about something like drowsiness detection? Let's go see if we can get that going. So I'll peel that piece up. And what that piece is going to look for is the landmark estimation on my eyes. So I'm going to look like crazy here, right? Because you see my green eyes and I kind of fall asleep and then it would wake me up as a driver, right? This is all AI at work in a... Okay, enough of that. I think it's also the boring meter. That means someone in the audience closed their eyes. That's what really that means. So it's this constant shift. And then now imagine how we can change this world. So this is Nicole McGinnis, and she's on this show called Beachfront Bargain Hunt. She goes in looking for her house to buy on the beach, and there's a thyroid doctor just watching on TV and notices a lump in her throat and sends a note to the producers to say, she has thyroid cancer. I know it. I can see it. And think about this world of selfies. Everyone taking pictures all the time, and they have a mole, and the morphology of the mole, the attenuation, the outside changes over time, invisible to the naked eye, but not a 17-megapixel camera, to try to predict skin cancer. This lady is alive because an expert in the audience bothered to react. And if we could package that expertise into AI, that is the mission that we're on. And so I've been in data for 23 years, and used to write books on data warehouse, and that was about finding the needle in the haystack. And then I wrote a book called Hadoop for Dummies with an H2O guy, Rafael Kos. And we wrote that book together, and that was about, looking back at that, it was kind of interesting. We tried to help you find the needle in the haystack, and then we said if you add more hay, you should be able to find the needle easier. And so many companies have fallen on their faces in Hadoop, where they didn't get the value that they thought they'd get. And today, with all the data coming in, quite frankly, you're looking at trying to find a needle in a stack of needles. And you need help, right? And so we need computers to watch, to feel, to hear. And that is where AI is coming from. And that's why I'm talking about your AI. And that's kind of like the first part of the talk. And I'll take you through some examples. So I still think my camera's filming me, so I'm going to try to turn that off without closing my eyes. And AI is really all about patterns. This is a dancer's pattern. What does that have to do with Super Mario Brothers, right? Well, we thought it would be interesting if we would go and take down some Super Mario Brother games. So if I kind of go and look at here, come out of here. All right, so here's a Super Mario Brother game. I'm going to just drag it in here, and guess what it is? It's just a bunch of hex codes. Those hex codes are no different than something coming off an IoT sensor, a feed on a production line. Absolutely no different. So we just want to find patterns. I mean, that's a big piece of what we're doing here. And so we put that into a neural network that would predict patterns the same way I would try to predict the next word that would to be written or letter. And here's what we came up with. Let's go starting out. So my Super Mario Brothers skills have gotten really good since building this demo. Hopefully I can get to a point where I'll show you. Okay. So here's the game we're starting. Now you see that? It's kind of broken. What is that cactus doing in the air? I suck, but I don't suck enough for you to see that didn't look like Super Mario Brothers, right? So then we continue to train the game. Continue to train the game, and that's the thing, we're iterating here, right? We constantly go through these iterations. And when we got to kind of well-trained, look where we're at after about a week of training here. I'll just run this game here. Okay, so here we're running around, and you can see it looks a lot better, doesn't it? Like there's still some mistakes there, but this looks like a real Super Mario Brothers game, and all it did was observe other games. Right? And so that's what I'm talking about. Now think about applying that to virtually any pattern that you can think of. Fraud detection, money laundering, AML, the requirements in FSS around KYC, know your customer, ideal customer profile, ICP. These are all the same use cases. And the beautiful thing about AI is we just change the data. And instead of telling the algorithm what to do and how to learn, it will figure out the rules on its own. And that's what makes it so magical, right? And so for the next thing I kind of wanted to teach, I spent the weekend doing this. It ran just on my my Mac laptop. It ran for about 2 straight days to try to teach the computer how to write like Sherlock Holmes, right? So I'd take a seed of 40 words, I'd feed into the algorithm, and then I'd start feeding it other words and letters, and it would spit something out. And on the first epoch, look at, it's garbage, right? And this is why it's important to iterate, how fast you have to go through this cycle. But I go to 50 epochs, 100, and by 150 FPOCs, so this is about 48, 52 hours of training, look what it says. "What are you so far as a communication?" said he. That sounds a little Yoda-ish, but that's pretty good, right? Look at the end. "I think you will do nothing of the matter." That actually sounds real. Imagine this hyper-personalized chatbot. That will be the tip of the spear of AI, where I come in and I use computer vision, voice to text, auto-translation, and understanding patterns. So when you have a conversation with me, you'll talk about the Toronto Maple Leafs and how they always beat the Winnipeg Jets when they play hockey, right? That's the conversation we'll have with me. So where can we take that? So I just teamed up with this group called Botnik, right? And they kind of create these kind of hyper-assist kind of writing tools. And I wanted to write a love letter to my wife because Valentine's Day is around the corner, right? And so as a corpus to teach the AI, I took the Civil War letter library corpus, and I mixed it with Yelp reviews from King's Dominion, which is an amusement park in Virginia. Has anyone been to the park before? Okay, there's things that I know about you, which are very interesting from reading those. So here's what the letter helped me compose, right? So I would put in like a seed. I want to say love, and it would suggest a line to write. So here's how it went. "My dear wife, King's Dominion is always a great many miles apart from your sweet smiles and friendliness. I was wounded in line for almost every ride." It's very tough in those lineups, right? But do you see how we're kind of creating like from what I taught it? Now I didn't teach it Sherlock Holmes, I taught it whatever this type of language is. "If you're looking for a weekend of rides and thought, I would give you any amusement I can. I would suggest you get unlimited refills from my heart." All right? Like, is she going to love that or what? Or is this just a tech thing? No? Thumbs up or down? Do I send it to her? Oh, yeah, all right. There you go. I got a lot of thumbs up there. All right. So these are the things that we create. Now I want to go from your AI to what your AI needs, which is IA, an infrastructure agenda. And it's like climbing a ladder. And when you think about when you're climbing a ladder at home, I climb that ladder. And, you know, as the higher I get, the scarier it gets, the shakier it gets, the slower I climb. But when someone's on their foot on the bottom rung and they're holding it like that, boy, you climb higher, faster, with more confidence. And when you look at that agenda, it has to start with infrastructure. And it's probably one of the most overlooked things. Look, I spent 23 years in software on analytics at IBM, and I went over to learn the infrastructure game, from storage all the way to GPU acceleration. And some of my friends from the old division were like, "Are you crazy?" And I was like, "Nope, this is the bottom rung." And upon that, you build your analytics foundation, you make data trusted and accessible, you scale your AI insights, and if I had to put something on top of that, interpretation. You explain why decisions are being made the way they're being made, because that is the biggest thing coming down the pipe for you folks. I love watching what H2O is doing around that area with Lime and the interpretability stuff. And I'll show you like a quick example. So here, I'm going to translate from English to Turkish. So I say, she is a doctor, and he is a nurse. So it translates. I'm going to translate that back. Watch what happens. She is a doctor, and she is a nurse. It changed the he is a nurse to she is a nurse. Why? Because of the corpus upon which it was trained. This is how modern translation is happening today. You ought to be able to go and explain why it chose that, because you literally just changed the gender, right? So interpretability, I'm not going to talk about it more today. It's a big thing, and I commend H2O and IBM with their trust and compliance on really pushing the forefront, because that matters. It's the most overlooked thing coming down the pipe in this manner. Okay, so what does an infrastructure agenda do? Well, much like this car, those who participate in AI are kind of like the privileged few, right? And the goal is, with the infrastructure, is how do we democratize it to the many so everyone can participate? And I usually show a Formula F1 car simply because, you know, you always see the picture of the driver, the obligatory pit crew, but you never see the hundreds of people that are in the shadows back there. They're all part of that racing team. In order to make data science a team sport, it can't just be left for data scientists. You guys are ahead of the crowd. You are the data scientists, but you will never be able to drive your organizations where they need to go if it's just you folks doing the work. And this gives rise to something I call the wisdom of the crowd. Imagine if I could take line of business to drive the initial stages of AI development, and I'll show you that workflow in a moment. And so then I could create thousands of ideas or hypotheses from the business, And from there, we would cook them through the business unit for sponsorship, and the thousands would become hundreds of validated ideas. Validated because we actually have some kind of neural network or CNN detection network for visual recognition built already, because I was able to build it. But I'm not a data scientist. And then I team with my data science team to make it perform better, to explore the hyperparameter space and make it generalized the way it needs to be. And then I team with DevOps to put it in production. And then I do the whole damn thing again. And that's how you transform your organization from an organization that harvests 10 to 20 algorithms and then pushes refresh rates every 4 or 5 months to thousands of them. That's how companies will be defined. And so if I look at this whole process, you kind of look at the far left and up and running. Look, in my Hadoop days, it would take people 3 to 4 months to get going, right? And then we enterprise harden stuff. So how do I backtest it? You look at OpenCV, stuff's changing all the time, right? So you want to go with a platform and a company, which IBM and H2O is doing, that can deliver you this stuff and say, hey, this is ready for enterprise. You don't just patch the latest version of whatever into the workflow. So instead of taking months, weeks, whatever, it's over a quick lunch. Here's the big piece. 80% of data science is spent not doing data science, doing data preparation, labeling data, wrangling data, getting data, finding out where that data is and its lineage. Imagine if not only could we cut that 80% to 30%, but we could take the data scientists who are in the purple and move them over here to higher value order tasks in our pipeline. All this has to be done, and right now it's all sitting on one person's shoulders. And then, of course, then we build, train, and optimize. Want to make things go faster? Our storyline for how we accelerate faster is both hardware and software. I'll talk about that in a moment. And then here's where I want to really have the data scientist here. I want them to explore the hyperparameter space. I want to feature engineer, right, so they can get better generalizing models. And then I do the whole damn thing again. And that's it. So we invite everybody there. How do we do that? So I'm a pretty big hockey fan. I thought if I was in marketing, could you imagine if I wanted to create an algorithm that could go and do ad appropriation time? So I have a new business model in which I charge you by the amount of time that your logo appears on the screen, or something like that, right? So you might see something like this. How do I build that in the life cycle? This is where we're going to hope my internet connection's keeping. So here I have a kind of a model here. I'm going to go label these objects. Now, this is a tool called ParaA Vision. See, what's neat is this is about vision, which is a hot topic. And the H2O driverless AI, which I'll show you, is about machine learning and natural language processing, also a hot topic. And they're both accelerated by the infrastructure. And so I come in here, you can see I have some video, and I can take some snap screens of this video, right? And they come down here. I can auto-generate them and let this thing load up here for me. OK, and do you see here I have the NHL logo? So I'm a business user. I haven't done anything. All I did was load a video. I think we all know how to do that. So I'm going to just type in NHL. I'll add that as a tag. I created it. I'll highlight it. And I box it. I just started creating a model. From there, I can go build that model. Right? Maybe the performance will be so-so, right? And I can expose that as a REST API. But I do more. Of course, we know that it's not necessarily about the best data scientists all the time. It's about the data. Right? So now I can go and take a pre-trained model and go train it on more and auto-label it. So let me get out of here. And since we're talking about how do we generate more data, a lot of data scientists do what we call these morphological operations in computer vision. Right? How do we Gaussian blur it? How do we rotate it, sharpen it, re-rotate things? So I can go and generate, you can see right here, my ability to generate more data. You can see how many data I'm adding to the set. And then I expose it as an API. That's about bringing people to the storyline. But then there's another piece. This young man here, his name's Derek Y. And he just joined my team. He has an undergrad in acoustics, and he's a first-year data science major at Simon Fraser University. So he's very junior. How do we up our game? And I think that's where I'm really watching this driverless AI do some pretty incredible things. So I'm going to just set the mood with some music around the Titanic Kaggle data set. On the left, you'll see Derek, before he knew what this product even was. I asked him just go to work and get to me 95% accuracy on Kaggle. And then we're going to put it through driverless AI. Here's what happened. "10 hours, 95%. I'm done, Paul. Oh, here's this tool called driverless AI. I'm done in an hour. It makes good better. Yeah, did I hear a wool? I think you give a round of applause, right? That's the magic here. Look at, I'm not saying in some cases with this and with the ParaA Vision, you can come in there and know nothing about data science, build a model that's going to score exceptionally well. That NHL model, scoring at 82%. But taking the average and making them better, that's what this storyline's about. And if you look at our characters, look where Derek is. Look what happened to Jack. He drowned. And so, you know, we saw our first customer come to market very vocally of what they're doing to tell you exactly what I'm talking about. It was Vision on Power 9. Double the propensity of banking customers to accept the offer with better accuracy. That's a tremendous story. So I'm going to finish out here in the next couple minutes, and I want to tell you about that infrastructure. So up in that corner right there is a Power 9 chip. It's an AI chip. And that chip's pretty incredible. I actually have it in my hands right here. That chip, I don't know if you guys can see that. That chip has 15 miles of wire on it. It's got more transistors on this chip than there are human beings on Earth. And if every human being were to perform 19 million calculations each at the same time, you would match what that can do. And this is why infrastructure matters. Because as we get deeper in accuracy for neural networks, we need to understand the computational efficiencies and what's needed. So what has this infrastructure that IBM's brought to market been doing? Well, for H2O, making data engineering faster, ingesting faster, machine learning faster, iterating faster. I mean, this is a storyline, right? If I look at the Power AI and the Vision stuff, taking models that would take 9 hours and reducing them to 4 hours. It's a great story. And what I want to tell you are two major things. This storyline is not just hardware. There is software engineering in that goes beyond compare. How do we get more memory access to these GPUs that don't have a lot of memory so we can support higher resolution stuff? How do we distribute workload? And then you kind of talk about, oh, a GPU, everyone's got a GPU. Sure. But on an Intel, because it's a closed architecture, GPUs talk to GPUs quickly, NVLink. In our architecture, which is open, not only do GPUs talk to GPUs, GPUs and CPUs talk more quickly, and they share memory coherency. And this is where you're going to end up as you go to the enterprise with your AI. You're all going to run in. This is the equivalent of a 5-year-old soccer game, if you've ever seen it. Right now, you're all used to using your own laptop, building your R stuff. You've got one server for your little team. That has not brought operationalized AI to the enterprise. And this is about workload management. And you're going to hear some interesting announcements next week, I think, right in the same place around this. So I'll finish you with these kind of two thoughts here. How do you get started? You get started whatever you want. Look, the fastest computer in the world, the Summit, was built with this building block. A number of components, and from there, you build what you want. If you want to build your small, medium business AI server, you build that. And if you want to build the fastest computer in the world, that's what you build. These get started quick blocks. And so I'll leave you with this. There's this, everyone knows chess and everyone knows Garry Kasparov. And you know that he lost to the Blue Genie machine in late 90s. And he held his head in shame. And days later, he came back. He said, you know what? I didn't lose to that computer because it's better than me. I lost because it's seen more chess games than I have. And so Centaur chess was invented. And Centaur chess lets you play it as an individual. It lets you play as a human with a computer. Or it lets you just play as a computer. And since Centaur chess was invented, there's been more humans playing chess than ever. And there's been more grandmasters. That's what I'm getting back to around the driverless AI. It takes good and makes it great. Why? Because they have lots of great algorithms that are baking inside. That's what we're doing with ParaA Vision. And if you look at the results in Centaur chess, you kind of look at it this way. Humans have never won games. It's always man or woman with machine, and they usually win the majority, or the machine. And so that's my time. I hope you get a feel just what a point in human history you're at in AI. Lift, shift, rift, or cliff, and what our companies are doing together to not only accelerate the speed at which you iterate, but the speed at which you get to the finish line. So thank you for your time.